This video is going to have a look at finding the geometric rule for a sequence where we don't have the exact sequence, but we do know two terms within that sequence. So the general rule that we are looking to find is Tn is equal to T1 times R to the power of n minus 1. So the two terms that we need to find to be able to write that rule is T1, which is the first term, and R, which is the common ratio. So we need those two terms to be able to substitute in to be able to write and use the rule. So let's have a look at an example of how we can do this, find the rule, when we only know two terms within the sequence. So in the example, it tells us the third term in a geometric sequence is 48, and the sixth term within a sequence is 3072, and it's asking us to predict the 11th term in the sequence. Now, to be able to make that prediction, we need to be able to have the rule, and to write the rule, we need the first term and the common ratio. We do have enough information that has been provided in the question to be able to do that. We just have to do a few calculations first. So as always, we should start off by having a look and see what information we do have. And we know that the third term is equal to 48. So if I was to write this for the rule, I know that the term value is 48, and that's equal to T1 times by R to the power of 3 minus 1. That's the information that I've got from the question, and I can also do that for the second piece of information, that the sixth term is equal to 3072. The 3072 is equal to T1 times by R to the power of 6 minus 1. So now that I've got that information summarized, I can go ahead and start my calculation. And what I do is I write them underneath each other, but when I'm writing it underneath each other, I want to put the later term first. So here I've got terms 3 and term 6. So the later term is term 6. So I'm going to put that up the top. So 3072, it's equal to T1 times R to the power of 5, because I know that 6 minus 1 is equal to 5. Then underneath it, I'm going to put 48, it's equal to T1 times R to the power of 2. So now that I've done that, I can turn that into a division. So I'm really dividing those two formulas to be able to find my common ratio. So when I do that, 3072 divided by 48 is equal to 64. And then T1 and T1 is going to cancel each other out. And that leaves me with R5 divided by R2. And using my second index law, where I know that if I'm dividing indices, I can subtract them, R is going to equal to 5 minus 2. So 64 is going to equal to R to the power of 3. So I'm getting closer to be able to find that ratio value. What I need to do now is I need to find the third root of R to get it to be R to the power of 3. And if I'm doing that to one side, I do that to the other side. So that's going to leave me with a value of R is equal to the third root of 64. So that is going to equal to a value of 4. So I know that my ratio is now equal to 4. So having found that ratio, I can go ahead now and find the first term. And to do that, I want to substitute back into an equation. And I'm going to choose the top one over here because it has the smaller value of 48. And this time when I write the equation, I'm going to substitute in 4 instead of R. So that is going to be 48 is equal to T1 times by 4 to the power of 2. And that leaves me with one unknown variable, which I can go ahead and solve. So T1 is going to equal to 48 divided by 4 to the power of 2, or 48 divided by 16, which is equal to 3. So my T1 value, my first number in the sequence, is going to equal to 3. So from there, I can write the rule, and the rule is going to be T1 is equal to my first term, so 3 times my ratio of 4 to the power of n minus 1. So Tn is equal to 3 times 4 to the power of n minus 1. So now that I've got this rule, I can go ahead and find my 11th term. And my 11th term is going to be when n is equal to 11. So I can substitute that in. So T11 is equal to 3 times 4 to the power of 11 minus 1, or 3 times 4 to the power of 10, and that equals 3,145,728. So that is an example of how I can find the rule of a geometric sequence if I only know two terms and their location within that sequence. And then once I find that rule, I can go ahead and find other terms within the sequence.